welcome to the Virtually Speaking podcast. My name is Pete Flecha, and joining me as always is my good friend, John Nicholson. John, what are you drinking there? I saw something.
This is Dr. Pepper, zero sugar and cream soda. So, the pride of Waco, Texas here. But
nice. Not sponsored by this product. I was just curious.
No. The 23 flavors are delicious, but I need the caffeine because I'm trying to chase down this networking issue. I've got this intermittent drop. I think I've got a bad SFP. I'm not entirely sure what's going on, but I'm going to figure it out.
Yeah, you're going to need to figure it out. And you're in luck because we are going to be talking some networking today. This is part of our continuing conversation around the advanced services that come inside of VMware Cloud Foundation. I feel like a lot of our, VMware customers or VMware by Broadcom, a lot of them are used to some of the more common advanced services. And it prompted us to do this series. And so we're going to continue that. This one is going to be on network observability. But for those listening, obviously go to the VCF YouTube channel listed below, and that's where all the episodes are. So the idea is we're walking through all of the advanced services that come with VCF. And as I mentioned, some of them are more common. You may be familiar with some of those. There have been some changes inside of VCF, starting with 9.0, like what's part of core and what's now what used to be advanced services. So be sure to start from the top of the series, and we have a great overview. But today we're going to dive a little deeper on network observability. We're not alone. We're talking to a good friend of ours on the show, Mr. Alec Pinkham. Alec, welcome to the podcast.
Thanks for having me. Yeah, excited to be on.
Yeah, so this is a unique one, and John always has networking issues at home and part of his life. So he's going to have a lot of questions for you. But yeah, this one's interesting, I think, from a VMware customer perspective, because most of the advanced services are just part of what VCF always had. Whereas what we're talking about today on network observability is actually outside of that. And it does work with VCF, but it's actually outside of like the business unit, if you will, of VCF. So super excited to dive a little deeper into this. Tell us a little bit about what you do at Broadcom before we dive in.
Yeah, so I am in the network observability group. It is really the combination of a couple of different technologies. So those of you who've been around for a while, the old CA technologies that was acquired in 2018 by Broadcom is where the DX NetOps product line comes from. And then I actually came in through an acquisition a few years ago as well that was for AppNeta. So combining essentially the old traditional monitoring of passive collection of SNMP data, flow data, things like that, with the newer stuff, which is essentially active monitoring out over the WAN, internet providers, cloud providers. And so we've stitched those together, and those have been kind of put together as a solution as network observability by Broadcom, which is what we're here to talk about.
Very good, very good. So like with that, I've heard a couple of different things. AppNeta, so like you said, you put these together. So maybe we could start from the very top. Like what is network observability and what might people have known it as previously?
Yeah, so the old traditional network monitoring was always about collecting passive data from devices, virtual or physical, right? Oftentimes in the old days, it was just the physical devices. You're getting SNMP data, you're tracking flows from switches, and you're kind of piecing those together to understand what's happening on the network. And the issue with that, it's still very valuable and very good data to have, but the issue with that is that it's reactive, right? You're only seeing an issue once it's actually happened to a user. You're only getting a trap from SNMP if you have them set up in the right places, if you're looking for the right devices. And so what we've done is married that with a newer technology, AppNeta, that's focused on sending test traffic from the end user perspective. So wherever the end user sits, whether it's in an office, at home, or if they're traveling from their laptop, we're able to look at the network from their perspective and piece together everything that's not that local area network that we already have passive data from, and basically get the full end-to-end picture of what a user experience for an app or service, or even just, communication between offices or between office and data center. So we're looking really at kind of that entire picture and then trying to understand where in that set of domains, so the LAN, the WAN, the cloud environment, the application service provider environment, where is the problem so that we can help kind of reduce the time that it takes to actually troubleshoot, triage, and figure out who's at fault when things go wrong.
So this is fun because I used to manage a I worked for an MSP, and we used RMM platforms to do real-time managed monitor tooling. And I love the R is supposed to stand for real time, but in reality, like there was always a lot of delay. So like on a good day, I was looking at maybe 5 minutes for a ping. I was looking at for deeper interrogations, maybe like 15 minutes for my SNMP collection interval. And I mean, maybe that's good enough, but the reality is users would call you half the time before you even hit your pull interval. So like beating the user on that is such a big deal. And that whole concept of like real time traffic, sending that stuff and generating that data yourself in real time. Um, this just seems like such a big improvement. Like, I mean, it's versus this traditional method of, SNMP and pings and hoping you have the right counters monitored and then having to self-interpret what that means and piece together different bits. That was, I mean, that was my job, but it wasn't fun, I guess.
Well, and if you look at the reality of apps today too, if you owned everything, if you controlled all the, all of the devices, right? When something goes wrong, you can go look at all the devices that are hosting the apps that people are using. But the reality today is that apps are in cloud environments. They're third-party apps that we rely on. We're working on a podcast that's on a cloud app right now, right? If we're doing all this and we don't have that visibility or we don't have the ability to test over time, then when you get the ticket or you get the call that says, hey, we had a problem, you've got no data to go on, right? You've got to start your ping and your trace route now. And the way that internet and clouds work, you might not be going over the same link anymore. You might not be going on the same, path in like both the macro
like
and the micro level
SD-WAN,
sense.
the path has changed, or
Yeah.
you've got LCP or some type of failover has happened. And like you say, with clouds, that gets real fun. And even private clouds, you have that because you may think, oh, these two VMs are on the, these two applications are on the exact same subnet, but there could be a software-based, SDN overlay. NSX could be doing that. You could have a hardware underlay that's doing that. You could have some type of ECMP fabric underneath you. And those two things that are like, oh, these are on the same /28. That's a pretty small network. They're probably right next to each other. No, they're in completely different regions of the US for some reason. So, or maybe someone just moved one, used HTX to, yeet that VM to a different data center or region. So trying to piece that together is challenging.
Yeah. And for a lot of network groups, it's almost impossible because they don't actually know where a lot of that data is going, especially when it's an app that they don't own or control and it's on an unmanaged network, right? They don't have that visibility. And so that's what we're trying to kind of give them back. And, obviously in the terms of VCF, when it's, in the private cloud environment, you have a lot of information from VCF, but you don't have the information from when that VCF app is accessing a microservice or a different service outside of VCF, if it's relying on something from Google or if you have some, replication going on between two services, you're not going to be able to see where that traffic goes.
So I could definitely see how this can help optimize a network by having this observability and gaining this insight. But what does it actually look like? Like, how do you do that if you don't own all of the pieces of the network? What is this that we're actually doing? What does it look like?
Yeah, so from the basic level, we talk about it as active monitoring. And what that really means is that we're curating a set of packets to send out over the network. So we're actually creating synthetic traffic that's going over the network in TCP, UDP, ICMP, and mapping not only the path, but also measuring the response to understand, what does it look like from the loss perspective, jitter perspective? Is there a latency or RTT problem? When we see issues, we'll automatically escalate and try to send more. But by and large, we're testing every minute to every path. If you have an issue, we're actually going to automatically escalate to understand if that is just, we caught a route change or we caught some kind of load balancing, and we want to make sure that we're, making sure that it's a real issue. And once we do that secondary test and confirm that's an issue, we'll actually go hop by hop and look across the link and try to get as much data as possible, whether or not there's QoS markings or whether or not there's, a change in the packet ordering or sizing within the network that's basically not allowed. We can look at that throughout the whole path and then just report back. And we're starting to layer in a lot more technologies that will kind of bring that to the fore through an alarm subsystem that will kind of say, hey, this is probably the issue. Everything downstream is not a problem. It's really just this one piece in the ICP, layer that we're, actually need to focus on and need to go call.
So from a from identifying, say, for instance, that like that tags, the QoS tags there, the COS or the DSCP tag or something like that is, are you going and triggering packet losses or packet captures in devices along the way? Or are you deploying agents along the hop path? Like, how are you getting that information?
Yeah, good point. So we're testing from the end user perspective. So somewhere in the end user domain, either on a laptop or in an office or in a data center, we have a device, virtual or physical. There's a couple different form factors, and those are what are generating the traffic for us. And we're sending that out. If we have a single-ended path, then it's just one device from that end user domain. It's sending out and just getting basically either mirrors and ICMP, or it's finding a couple different ways to get and measure responses across the network. If we have a device or some way to look at both sides, I say some way, we've got global monitoring targets that you can do on the far side that basically act as a user device or act as an agent.
You have those multiple different places, and you can say, okay, it's good from 3 of the 4, so it's probably something unique to this segment from that shared path.
Yeah, and oftentimes we're trying to identify if it's a user-specific problem, a location-specific problem, or an app-specific problem, right? Because if you get a response and says, hey, John's having a problem with this app, right? One, we have to know where John is. We have to know, where he's like physically located, what, device, like a lot of that can be reported
Building
easily.
6, third floor, one half bar of cell service. Why is
John's
my app
very
not
hard to
working,
find.
app owner? Why is my app not working? No, but I mean, I used to do VDI, and VDI is, virtual desktops. When you get slight amount of packet loss, people get violently angry. But being able to say like, hey, you need to go find reliable Wi-Fi or troubleshoot, isolate that out, versus understand, oh, this is a generic issue, or this is inside the data center networking, But I feel like there's almost like a political fight sometimes of trying to. It's not necessarily blame. There is no 3 blameless when it comes to troubleshooting with users. There's often kind of an animosity of like, look, you're trying to put the best effort in, but you're also not trying to waste 3 hours of your life troubleshooting the fact that they have a 2G edge connection or something in the Himalayas. So.
Well, and that's a big part of what we talk about with network folks is that it's often mean-time-to-innocence, so MTTI, more than it is mean-time-to-resolve. It's how fast can you prove it's not your issue? And oftentimes that's either pushing it to the ISP or the cloud environment. Apps are pretty resilient these days. They don't go down very often, right? When AWS has a problem, it's major news, right? So if they're not going down, then what are we complaining about? Well, it's slow for, is it likely an app issue? Maybe, sometimes. It's oftentimes somewhere in the network, and that's where their network teams are used to being blamed for that.
So a lot of that seems like reactive, right? It seems like, oh, if there's an issue, let's figure out what's wrong and try to fix that. Is that the primary use case for network observability, is troubleshooting?
So the goal of network observability, and I've worked pretty long on with our group on a maturity model, is we want to get more into the proactive stance. And so there's a lot that we're doing right now and have been doing to analyze the data and look at everything from standard deviation from baselines for normal application performance to tracking and trying to essentially alert the user that it's trending in the wrong direction. There are things that happen in networks that are just kind of normally just pop up automatically, and you're not going to catch it beforehand, right? If you get a route change or a device goes down, that's going to be just an immediate impact. Now, there might be some load balancing, or as we mentioned earlier, SD-WAN, right? We might be able to switch tunnels, but you're going to see an impact to some users at that point. What we're trying to get is to the proactive level of, even if you don't catch the issue beforehand, when you have it, you're immediately given the data that tells you where the problem is. And that where is usually the issue, right? Getting to where is, oftentimes if you can point to an IP address, right, that's half the battle, right? Then you go to that device and you can start playing around and figuring out what exactly it is. But that's only the case if you own it, right? If you don't own it, then you got to call someone. And oftentimes pointing to the exact IP address helps them troubleshoot the problem a lot faster.
Makes sense.
Yeah, absolutely. So what other use cases are there? Like I've heard someone talk a lot about, like, when you're prepping for a migration, this might be something that you would use. Is that a standard use case for customers that are looking at this?
Yeah. So one of the biggest things that we've realized is that with larger migrations of applications, clouds, what have you, when you finish the migration, there's often there's a common issue where as soon as an app becomes slow right after the migration is blamed. Whatever that change was, whatever it was last change is immediately blamed. And so we got to this point where network engineers, and I think cloud operations has the same problem, is they need to prove that the migration was successful. And there are a lot of different ways to do that. But one of the ways to do that, in our perspective, is getting the end user experience kind of baselined beforehand to understand what it looks like. Because if you have global user bases, if you have even global customer bases that are accessing this application, you might not know what normal looks like across the globe. You might know what your experience with that application is, but you probably don't know what it is. I'm in Maine, right? North Carolina to Maine to California to Texas, right? It could be totally different.
Well, what's fascinating to me is people normalize like really bad experiences, but it's just always been that way. Like I talked to someone once who
Yep.
there was a file server in his office in Houston, but he had to connect to a Citrix session in Tokyo was his workflow, and then it just opened an SMB call like over a VPN tunnel back to Houston. When and it was like he would sit there and like it would take like 5 minutes to do something that should have taken 3 seconds, but he was the new guy and he started asking questions like, it's always been this way. Or I've worked in places where, the Windows login took 5 minutes because of a profile, a networking issue to the profile server. And like hundreds of people were under like collective hypnosis of like, oh yeah, this is just normal. It's always been this way. And I like that idea of one, benchmarking it because and understanding what's, from an anomaly detection or that, or maybe, okay, yeah, latency from the US to India is just never great. But on the other hand, you may find that users are just experiencing some type of collective pain that they've internalized as normal, and you might actually be able to go proactively liberate people from some really offensive networking problems.
Yeah, I think you're totally right. I think that as we've adopted, more applications, we've become tolerant that they should all be very, very fast, right? We assume that it's coming from a cloud environment, but if you don't have that experience in the past of I remember this FTP server from the Czech Republic office that I had to connect to back in an old work zone, it took a while because it's got to go through all the checks and balances to get there. And I think that disparity between specific applications means that if IT is changing something, they may not know what my normal experience is. And so, being able to baseline and benchmark beforehand and then compare it afterwards is not only the way to prove your success, but also maintain the innocence of nope, actually, it's either better or equal to what it was before, right? It may not be worse, or if it's worse, I better have a good reason, right?
Absolutely. Yeah. So I know VCF 9.0 came out, and I know that this, and that was the first time I heard that this was available as an advanced service for VCF customers. Is that the baseline? So you have to be on 9.0 to start taking advantage, or is this anybody could use it?
So it's agnostic. The whole system is basically agnostic in a lot of ways. So from the DX NetOps side, it's been device agnostic. We certify more devices than anyone in the market. So we can basically pull those devices, pull data, put it in topology, right? Give you a full map of the network. From the Apneta standpoint, we're just testing from one location to another or testing out to a FQDN, right? Some kind of IP address or fully qualified domain name, easy for us to access. So both are in a lot of ways agnostic of using, pre 9.0 or pre 9.x to after. I think the reason that we were, working with the VCF team originally was, hey, this is a big migration for a lot of people. It's going to have a lot of moving parts. And this is a great example where we can kind of bring in that idea of let's benchmark beforehand, because even if you're not using us beforehand, getting that mentality of looking at it from the network perspective and not just the cloud operations and the app perspective is going to help them in the long run. And so that's really the focus. But I think as we move forward, there's currently some levels of integration today, but we're also have a roadmap for bringing more and more data kind of bidirectionally through whichever interface you're working. If you're in the cloud operations team, being able to pipe some of that path data up to the VCF console. And the same to the Apneta side is pulling in some of the virtual device data or virtual environment data into Apneta.
Oh, okay. Yeah, you had mentioned DXNetApp and then AppNeta as separate. So, but they are essentially, though, that is the aggregation for those that have never used it before. It's DXNetApps and AppNeta as both network observability.
Yep. Network observability is our solution. Right. It's kind of the higher level, just the packaging of everything. But for anyone who's familiar with either product line, they may have a better idea of what each one of those does. So I kind of say both. And what we're showing here is really kind of the three core parts from the AppNeta side that make it immediately valuable to anyone using VCF, because we've talked a lot about the network synthetics right now, but there's also a web synthetics and like API monitoring kind of baked into AppNeta that will allow you to get baselines for application performance from the network and the app perspective and from that end user perspective. So what I mean by that is from the agent on my laptop or in my office out to the applications that I care about as, someone in product marketing, or maybe, an engineer cares about from the engineering team. And then we're also able to do that WAN kind of connectivity network experience that we've been talking about, as well as kind of map that to kind of the end user experience performance, and kind of give you better dashboards for what that normal looked like beforehand. So it kind of brings that all together to provide it for someone who might be migrating to, 9 dot whatever.
Very nice. Well, I know there's a lot more to cover, and I know we don't have you for too long, but I did want to point, there is a short link below. If you're watching this, if you're listening, go to the show notes of the podcast and you'll be able to get these links. But there's some really cool content. There's a landing page link below for network observability that covers all of the features. And it even has some recent blog posts, but also like a good demo video that sort of walks through this whole thing and shows you what it looks like. What else do we need to know about network observability from a VCF perspective?
Yeah, so I think the core components that we are working with on, like any kind of customer that's working with VCF, is we're trying to analyze and understand what the hybrid environments look like, right? Obviously we're working with VCF more and more, but it's not that it's new to us, but it's new to everyone in the sense of, how is the architecture actually looking for people in reality? And so I think that's one of the biggest things. Is I mentioned that, it's an agnostic system. It's going to be able to monitor any type of network, but understanding, how customers are setting it up in comparison to what the kind of vSphere setups were in the past, or even earlier VCF incarnations, right? How are we actually connecting to other kind of disparate systems? So what I mean by that is other cloud environments. So, AWS, Google, Azure. How are we connecting, office to office or from data center to office? Is that changing? We know that we're very successful at looking at SD-WAN tunnels because we've for a long time done overlay-underlay comparison, and we know that that's a big part of a lot of VCF deployments. And so understanding kind of how that fabric's done is something that we can offer to anyone who's setting up VCF in a new location or even just migrating in place. So I think that's kind of some of the core pieces, the hybrid environments, as well as the software defined kind of anything, the data center side or SD-WAN. The other components that I would say is, over time, I'm really from the networking side more than anything else. And so looking at how cloud operations is approaching this problem in this migration versus how network operations, one of the things that I've realized is that depending on the organization, there is either a lot of talk between those two groups or not a lot of talk between those groups. And so it would be great to see more and more of that. And I think this is a great way to bring up kind of networking in the context of cloud operations and kind of how important it is to make sure that fundamental network connections is if not set up correctly, at least monitored to understand when it actually impacts the VCF environment.
I like it. Very good stuff. Alec, thanks for joining this series on VCF Advanced Services. I do feel like, as there's a lot of people that have just signed up to VCF that are actually migrating. I think 2026 is going to be a year filled with migrations, and I feel like network observability is going to be a big part of that. So as we start to get feedback from customers and we start to hear some more, maybe we can have you come back on and do another episode on this. I know there's another podcast that's on the CA side that actually covers a lot of this in detail. What is the name of that podcast?
Yeah, so that's the NetOps Expert.
Yeah. Okay. So I'll throw a link of that in the show notes as well. The NetOps expert, and I know you're not the host of that, but I imagine you're a frequent guest.
Yeah, often on it. Jeremy Rosbeck, a colleague of mine on my team, is a great host of that and does a great job. But yeah, he usually pulls me in when he wants to talk, back and forth instead of just on his own.
Yeah. Well, John, John's always been my network guy, but I think I got a new network guy now.
I'm the worst networking guy, but here I
am. You're not too bad as far as I'm concerned. John and Alec, thanks so much for joining us on Virtually Speaking, and enjoy the rest of your day.
Thanks so much.